let's get started. We are in chapter 1. So this is sampling and data. So I have come across this statement sometimes from students. Not everybody, but sometimes people say different forms of this statement that I'm not good with numbers. And some people obviously hate statistics, and especially in business school, people wonder like, why do I have to study this kind of subject where you have like data and all kinds of analysis? That should be done in probably math department. Usually, I give this equation that this is anybody who feels like that is almost saying, because in today's world, you go anywhere, in business especially, you have seen all these examples in the presentations, everything involves data. And having some skills to do something with that data is like something everybody is expecting, businesses. They expect you to do something with the data. It could be simple graphs, charts, data visualization, like dashboards, or some analysis. Any interview you go to, whether whatever may be your major, whatever may be your focus, they may ask you to make a presentation by doing something with the data. So data is like everywhere, and I know like for some people it may be something out of the comfort zone. But I really feel that university is the one place where you can go out of your comfort zone, and people say that if you do that, you make your comfort zone bigger. And university is the best place to basically expand your comfort zone by doing things that you find challenging or going out of your way to learn new skills. The good thing is like we are in business school, so in this class our objective at the end of the semester is not to expect that every student becomes a professional statistician. That's not the goal. It's difficult, like one semester nobody can become statistician. But the idea is that by the end of the course, you are able to understand a few things about data and what methods are applicable in different situations. So you have a business problem, you have some data around it, and then you have some tools in the form of statistical methods. So you should be in a position to make use of the right tool and apply that to the data so that you get the best outcome. Or most of the hard work nowadays is done by the computers. So all of you have access to computers. So most of complex analysis is easily done by your computer. So what is our role? Our role is to make interpretation. So you feed the data to some black box in your computer, and it gives you output. Now, what does it mean? So that interpretation we should be able to do. So in a way, you can think of like to drive a car, you don't have to become automobile engineer. If you just know the basics like how to switch it on, how to use the accelerator and steering wheel and all those things, you will be able to drive automobile. So same idea here. You don't have to become statistician to actually start using statistics. So we have seen many examples, but let's look at some more. So many of you mentioned you have interest in stock market on the first day. So that's one area where a lot of data gets generated. You have so many companies like S&P 500 has 500 top companies listed. You have NASDAQ, you have Dow Jones. So there are so many companies and so much of data gets generated, like data related to the companies, data related to the stock prices. Every second you have a data point, and making sense of that data, analyzing that data, when to invest, when to keep the stock, for example, if you are in something, when you should go in, when you should come out. So all those things may require some kind of looking at the data, analyzing the data, and then making a decision. Sometimes it is done by humans, but big companies now even do it by using computers. So there is algo trading where algorithms are there and they make a decision in a fraction of a second, because human beings may take more time, but they can decide within fraction of a second. So companies like Goldman Sachs, they make a lot of money from that kind of trading, high frequency trading, so in and out. And that is done using computers. But then they also need people. So they have a lot of people who can do things with data. So stock market is one big example. Another application is demand forecasting. So every business needs this, using the data, like how the demand patterns have been in the past and projecting it to the future. That's done by every business. Everybody wants to know, like, because they have to plan. So if a car company, for example, knows that for us the demand is likely to be 100,000 cars next year, so accordingly they will plan. Production capacity, how many people to hire, what kind of resources they will need. But if they have to produce like 1 million cars because demand is very high, then accordingly they may have to open new plants and things like that. Government depends a lot on demand forecasting. They look at a lot of data points and see what is needed and then plan for next year, like where they should put their investments, where they can build roads and whatever. So all the planning at any level is driven by demand forecasting. And you do demand forecasting using statistical methods. Another example is health data. That's one huge sector where you have lots and lots of data. That's one area where there is huge potential for applying statistical methods in so many ways. I had a PhD student 2 years back, and her PhD focused on health data. So she used health-related data to develop some machine learning models and make predictions. One of the papers that we wrote, so the problem was that in old age, old people when they walk, sometimes they have a problem of freezing of gait. And what that leads to is, that could lead to a fall. And somebody who is like 65 plus, maybe 80 years, 90 years, if they fall, it could be very dangerous. So what she did in her research was, she used some sensors, putting it on knees, close to hips, and near like ankle, and collected data for like people walking or sitting. And after collecting the data, idea was, can you predict that freezing of gait event is about to occur, so that if you can predict even 1 second earlier, so those people can be, nowadays we have like Apple Watch or some gadget that can alert the person. So wherever that person is, simply sits down or becomes alert and avoids a fall. So that is just one example, but there's a lot of research going on. One of the articles, among those 1,000 articles that I shared with you, one of the articles talks about using a single heartbeat to predict heart attack. So using that data for making that kind of prediction. So health data definitely has a lot of scope for applying these methods. This class is about business statistics, but what is statistics? So statistics word is used in, it has two meanings. Sometimes it is used as a plural, and sometimes it is used as a singular. When it is used as a plural, it simply means data. So data that we see all around us. It could be student data like name, age, class taken in a semester, and so on. But when it is used as a singular, then it is defined as science that deals with data collection, analysis, interpretation, and presentation of data. So science that deals with data collection, because how you collect data is very important, because that will lead to what kind of data you have, what is the quality of data. For example, there are so many different strategies we are going to look at later on. If you want to predict, like recently we had that debate between two candidates for the president position. So if you want to predict who will be the next president, and if you collect the data, let's say 1,000 people, so that's a big sample size. So you ask 1,000 people and you have data from 1,000 people. But if that data is collected just from maybe Chartered College of Business, so all the students or faculty within just Chartered College of Business, although it is data and you have collected that, but it may not be representative data because it is collected in a very narrow area. So whenever we do any analysis, when we have to collect data, that data has to be representative of that big thing that we are trying to study. So it has to be spread across US among all the voters who are likely to vote. It cannot be like concentrated in one area. So otherwise we have bad data, and whatever predictions you make will not be accurate. So data collection is very important, because there is another term in computer science, it's called GIGO. Anybody knows what is GIGO? Yeah.
Get in, get out.
Close. Anyone knows? No? Garbage in and garbage out. So any tool you use, software you use, or analysis you use, if you are putting inside garbage, your outcome is not going to be good. So if you have poor data quality, whatever sophisticated analysis you do is useless. So data may be collected. If it is good, you have to carry out proper analysis and use the right methods, right tools, then only you get the best outcome. If you have done good data collection, you have done good analysis, but if interpretation is incorrect, the data says something and then people start misusing it, because that happens a lot. And that's one thing that causes some people to believe in that statement that British parliamentarian once mentioned, lies, damn lies, and statistics. So statistics is the worst form of a lie. And how he came to that conclusion? Because people were coming and interpreting the same data and analysis in totally different ways, just to suit their point of view. That can happen, so we have to be careful, we have to do correct interpretation of the data so that it doesn't happen. Now, if somebody misinterprets the data, like you cannot blame statistical methods for that. For example, we have a knife which can be used for cutting fruits and vegetables, but somebody can use that knife to kill someone. So we cannot say that this knife is wrong. It's the people who are misusing a tool. It is their mistake. It's not like statistical methods. You can blame that. That's the root cause of all the problems that we see around. So the biggest problem comes when people misinterpret and start using the data in an incorrect way. So that's why we have to be alert. Like, that's why we study statistics, so that we make sure that we are using it in the right way. Now, you have a very good data collection. You use the right tools, methods. You do the correct interpretation. But in today's world, if you do not present that properly, then people start having doubts about all the other things. So if somebody comes in a business like meeting and has done hard work and done everything like nicely, but presents that thing in a very, very poor way, so people will start doubting that whether the data was good or analysis was done correctly or not. So nowadays presentation makes a huge impact. So that's why, especially in business school, you'll see most of the classes has some kind of presentation, so that you keep on practicing that and improving yourself by the time you reach senior year. So that is like statistics when used as a singular. When you are just talking about the data, like data on economy, we are talking in the plural sense. Some people say like data is the new oil. Probably we can add to that. You know, like crude oil, how much it costs? One barrel is, I think, close to $70. It has come down a bit. But when it is processed, and what can you make out of it? When that oil is processed, crude oil, what do you get? Yeah?
Gas, gasoline.
Yeah, gasoline. So that sells for how much? If you compare that number, per barrel will be almost like $2,000. So something that was 70, after processing, you make it more valuable, right? So data is there, data is oil, but I would say statistics, the science of it, doing proper analysis and everything, makes your data much more valuable. You may have data, but when you add some value through the analysis and everything, you make that much more valuable. So that's what actually is the focus of this class. Let me break it down to two parts. The statistics I will divide the second one, which is like science of working with data, that statistics broadly into two categories. One is descriptive, and other is called inferential. Inference, it comes from inference, so inferential statistics. There are two types broadly that we deal with. Now, what is descriptive statistics? It just, as the name indicates, it just describes the data or summarizes the data. So you may have data, you may put that in tables. You can put that data in the form of graphs and charts. So graphs and charts, and it could be numbers. So you may summarize your data in tables. You may see in magazines, in newspapers, or TV programs, data organized in the form of a table. You may see data organized in the form of graphs and charts. Like people say, a picture speaks 1,000 words. So if you have thousands and thousands of data points, and you make a picture out of it, and you have like 50 people sitting in the room, so everybody can come to some conclusion very quickly. But if just presenting them all the data, it can confuse a lot of people. So graphs and charts are very popular nowadays, especially when you have a lot of data. It makes understanding what's going on much easier. And then sometimes we summarize data in numbers. So numbers could be percentage, for example, calculating what percentage of people are likely to vote for one candidate, or what percentage of people will vote for second candidate, something like that. So that percentage is a number. Or finding average. What is the average age of students in a particular college? So sometimes we summarize data in numbers also. But this is just describing the data, and you are taking the data and just putting it, organizing it. Statistics is all about working smart. So instead of like looking at each and every data, you are smartly putting that in a graph so that people can understand what you're trying to say. Now, inferential statistics is basically going extra step to draw conclusions, trying to understand a business problem and then trying to find a solution. Let me make a small flow chart here. There's a term called population. In statistics, very often come across this term called population, which means population of interest. So if we are interested in which candidate is likely to win, and we want to do a survey, then population of interest is all the voters, right? Not everybody in US. It's just all the voters who are likely to vote in the next election. That will be the population of interest. We cannot say that all the citizens, because some people cannot vote, they may not be of that age. So population is something in which we are interested, and usually it is big. And if you have to collect data, like you'll notice that almost every day or every week, people have data on who is leading the race. Now, if they have to ask each and every voter, that will be very, very expensive. So what is the solution? Instead of asking everybody, you ask a smaller number of people, and that we call sample. So from this population, we take a sample. So that population has something of interest to us which we don't have access to. Obviously, in that population, there will be some percentage of people who are likely to vote for a particular candidate, but we have no way of knowing that. So what we do is we take a sample, a smaller sample that can be done in less time, less money, and then use that sample and do a further analysis to figure out what is going on in the population. So in the population, you have a term that we use in statistics is population parameters. So population parameters are those characteristics that we are interested in. It could be some average in the population, or some percentage, or some variability, or whatever that we are interested in. But what we do with sample, based on that we calculate sample statistics. So based on sample, if you calculate a percentage or average, that becomes sample statistics. Remember, there is nothing called population statistics, or there is nothing called sample parameters. That will be incorrect use of the words or terms that we have in statistics. It's population parameters and sample statistics. Now, when we are taking a sample from the population, I mentioned to you that it has to be a representative sample. A lot of effort has to go into that, like how you are collecting the data. You're not asking like 1,000 students in Chartered College of Business and claim that I can use this data to make a prediction about the whole US. So that will not be a representative sample. Now, another thing is, like, many times people ask, should we take a small sample or big sample? Now, small sample will be less expensive. Larger the data you need, more expensive it is going to be, right? In terms of time, effort, energy. But then there are situations where we may have to do a big sample. Now, one simple rule is, if your population is heterogeneous, if there is a lot of variability in the population, then the sample has to be big. A small sample will not do. So if a lot of variability in the data, like if you're talking about 100 million voters across US with so many different views, and if you take a sample of 10, it may be spread over like US, but that's too less, right? You need a bigger sample because your population is heterogeneous. Similarly, if the population is homogeneous, so homogeneous means similarity within the population. You have like things which are very similar to each other, then we go for a small sample. One example is like when you go to a doctor for a blood test. So one drop of blood is enough to figure out like what blood group you belong to. They don't have to take out like entire blood from your body just to figure out you belong to A or B and so on. That's because blood in our body is like homogeneous, whereas some other situations we have a lot of variability, we have to go for a big sample. So sample, we have to be very careful that we get a representative sample depending on what you are looking at. Now, when we have that kind of sample, we collect data or we record data from that sample. We do analysis. We apply appropriate methods. And based on the analysis, you have some result. You have some result. So my question to you is, now that we have some result, where does this result apply? Should we apply this result to sample or the population? Which one you think? Because results can be applied to this or it can be applied to this. So which one should we be doing? Yeah. So results we apply to the population because that's what we are interested in. Sample, we know everything. Once you take a sample of whatever size, you have all the data. You don't need to do anything in the sample. And the whole idea of taking the sample and going these extra steps was to figure out something about the population. We are not interested in this. We are interested in this. We want to apply those results back to population. So this journey of starting with the population, finding a sample, collecting data for that sample, analyzing the data, getting the result, applying that result back to the population, this whole journey is called inferential statistics. So that's what this second item or second category of statistical method is, inferential statistics. So descriptive statistics is very basic, graphs and charts, tables, numbers, but inferential statistics, you go some extra steps, you do some extra things. Many things are automated nowadays because you have computers like using the right statistical methods and all that. So that's what is called inferential statistics, and that's where we spend more time in this class. Now let me ask you a question. Suppose there is a EV maker, there is a company that makes electric vehicles, and they create, so they are always doing some kind of R&D. So they create a battery that can give up to 900 miles. So once you charge that vehicle to 100%, it can drive for 900 miles. Obviously, that is a breakthrough kind of situation in their R&D. This is still research and development work, and usually they have to do a lot of testing to make sure that the results in the lab will replicate in the field also. So you may have done some analysis and figured out that if you do this to a battery in EV, you can increase mileage to 900, but then it has to be tested. So somebody has to make prototypes, make some samples, get data and all that. Now suppose they create 25 prototypes. They create 25 samples of prototypes and do all the testing that is needed, like whether it gets heated and whatever, how much time it takes to charge and so on. My question to you is, in this situation, what is your population size and what is your sample size? So you have some data now, 25 prototypes. So anybody wants to attempt this, like what is the population size? Yeah. So population size is 25 and sample size?
Okay, this might be wrong.
They have made 25 prototypes or samples and tested all of them.
25.
So I'm just writing down and then we'll see. So one option could be both are 25. Any other thoughts? Yeah.
So would the population be like all the batteries, and then the sample size would just be the 25 prototypes?
So what do you mean by all batteries?
Like prototypes is just this, like them sampling it, and then once
So they have not made anything else. They have made, this company has made only 25. There is nothing else they have made. But you are saying like, when you say all, you mean like,
like once they like mass produce it, I don't know.
yeah, so in future, who knows, like, so it could be all and sample size 25, right? Sample size 25, that makes sense? So I think that's what we talked about. If you look at this flow chart, what are we interested in? We are interested in the population Why this company is doing a testing of 25 prototypes? Because they want to make sure that they can mass manufacture, as he correctly pointed out. It could be next 5 years, 10 years, who knows? It is so successful that they can continue to do that for like 50 years. So there's no limit to how many they can produce. It could be infinity if the design is successful. But if the design is not successful, if they do all the testing and they find that it's not practical, it gets heated too much, leads to lots of problems, or it is too expensive, like to create these batteries. So they just end with that. The story ends there and they move on to the next project or try to find out like some solution why it is heating, why there is a problem. So they just stop there. So in fact, population size could be from 25 to maybe infinity, and sample size obviously is 25. The key point here is that the population in which we are interested may not exist today. It may exist in the future. So that also is possible, because ultimately why we are doing a prototype, because we want to understand what will be situation in the population of our interest if we go ahead with this product. So basically trying to see and understand some of the definitions.